Hello, I'm Harshad Sathaye from Northeastern University, Boston. GPS spoofing is an attack where an attacker transmits fake GPS signals such that the receiver calculates a false location. With the presence of constant threat of GPS spoofing, existing countermeasures prove to be insufficient. They either require significant changes to the receiver, like cryptographic solutions, or provide only spoofing detection capabilities. To overcome these shortcomings, we propose SemperFi, a spoofer eliminating GPS receiver which is designed to provide uninterrupted legitimate locations even in presence of a strong attacker. There are two main components of SemperFi. First is the adversarial peak identifier. It is responsible for distinguishing malicious signals from legitimate signals. In SemperFi, we have incorporated auxiliary peak-based spoofing detection technique which can detect even a strong attacker. The legitimate signal retriever uses the principle of successive interference cancellation, where it generates a replica of adversarial signal and uses it to attenuate the spoofing signals. To recover from scenarios where the attacker completely overshadows the signal, we implemented a pseudo-range rectifier as part of the tracking module. Based on signal recovery, it can rectify pseudo-range measurements while using attacker's navigation messages. Unlike most CDMA systems, implementation of SIC in the context of GPS possesses a unique challenge, as it is important to recover not only the legitimate message but the time of arrival of these messages. SemperFi can work as a standalone GPS receiver, or it can be used as a filter which can feed the recovered locations to a conventional GPS receiver. A working model of SemperFi is implemented on Soft-GNSS, an open source single frequency GPS and Galileo receiver written in MATLAB. It allows granular control over various processes incorporated in a typical receiver. Effectiveness of SemperFi was evaluated using various datasets: synthetic GPS traces generated using GPS simulator, a public repository of GPS spoofing signals, and live recordings. Various spoofing scenarios were simulated in these traces, including strong seamless takeovers. This is our experimental evaluation setup for recording live signals with active spoofing. To evaluate the effectiveness of SemperFi, we look at the accuracy of recovered location. Plot A shows the recovery of a simulated dynamic motion represented as northing and easting. Spoofer starts at point A. At point B, attacker starts introducing offsets, and at point C, SemperFi kicks in. Average deviation of recovered path is 10.109 meters easting and 2.692 meters northing. Plot B shows recovery in TechBat's dynamic push scenario. Obtained accuracy is 108 meters in the Z-plane. Plot C shows a comparison of location accuracy as obtained from GPS simulator traces, real-world signals, and TechBat's power-matched position push. One major factor which affects recovered locations is attacker synchronization with legitimate signals. In other words, the effectiveness of eliminating spoofing signal depends on the temporal shifts in the time of arrival of legitimate and the spoofing satellite's navigation messages. This is evaluated by generating spoofing signals with the respective peak separations in nanoseconds. As you can see, accuracy of recovered location increases along with peak separation. An attacker with power advantage of about 15 dB distorts the legitimate navigation messages, making it difficult to track the recovered signal. SemperFi uses pseudo-range rectifier for recovering locations. This plot shows accuracy of recovered location in presence of an attacker with power advantage of 15 dB. The 15 dB limit that we have set is a pure DSP limit. It can be extended by using smart directional antennas. To summarize, in this work, we presented SemperFi, a spoofer eliminating GPS receiver. It was designed, implemented, and evaluated against various datasets. SemperFi can recover with an accuracy of 100 meters and power advantage of an attacker up to 15 dB. Thank you.